Welcome. This is my very first uh, AMA session, and I can't even think of I'm supposed to say. And I hope you can hear me because my audio is working fine. Happy Friday. That's one. Happy New Year. Two. And happy 2022. That's three. Three, three things. Can't believe time flies really, really fast. It's 2022 or 1 week into the new year, and 2021 just went by so fast. Just like anything else, when you're really caught up with so many things that you have to do. Welcome. This is the Practical SQL Server HADR AMA session, and I intentionally prefixed practical because I've seen cases when I'm working with either clients or customers or even people who are in my training classes who would ask questions, but then all of a sudden when you ask them, so what are you going to need it for? And typical response is, well, we're thinking of doing this. And they haven't counted the cost of what it means to implement something like that. And I'm a big fan of turning information into action, right? We've heard so many people talk about information is power, knowledge is power. I don't really believe that anymore because with the internet, everybody has access to information on their phones, and not everybody is taking action on what they're learning. Okay, the biggest distinction is really about taking action on what you know. Okay, and that's one of the reasons why I really want to focus on practical emphasis on the practical here. My name is Edwin Sarmiento, and I am a Microsoft Certified Master for SQL Server. I have been doing high availability and disaster recoveries for almost 15 years now. And I wanted to share some of the experiences that I've gone through, my clients' experiences as well, and also take a totally different spin on it. How can we apply these information? Okay. Again, I'm a big believer in taking action in what you know. Okay. And so I've collected a bunch of these questions from people who have submitted those questions. And thank you for that. I am still figuring out how to work around these different social media platforms. I know when a question would come in through LinkedIn, I will be able to see those. Or if a comment comes in through, I'm not quite sure how that works with Twitter and YouTube. We'll see. Let us get started with answering some of the questions. And what I did was, one of the reasons I asked people to submit those questions way ahead of time is because, number one, it makes it fancy to like have a banner scroll in, and not just me being able to read those questions, but you can read those questions as well. Plus, I like making, I like using analogies that people can relate to. Some of the things that you already know, and I'm just putting things together. All right. First question I have on the queue. I don't know if this is a question or if this is a comment because there was no question mark at the end. So I'm assuming that this is a question. Clustering of SQL Server without using Windows clusters. And I did emphasize on the practical word there at the start of the title. A little bit of a background. SQL Server 2017 introduced the ability to run always on availability groups on what they call clusterless infrastructure. Not a big fan of it. For one, it's not because of the technology, mind you, right? So this is probably the question, what the question is all about: clustering SQL Server without Windows failover cluster, or cluster resource technology. I'm going to use a generic term here because starting with SQL Server 2017, you can run availability groups or failover clustered instance on Linux. So no need for Windows, you can use Linux. So clustering of SQL Server without using Windows clusters, you can use Linux. Pacepaper, if that's what you're thinking. No. One of the reasons I'm not really a big fan of it is because of how embedded ideas are within us. And what I always tell people, it is easier to learn something new than it is to unlearn something. It's like eliminating an old habit. And when you think about clustering, whether it's for Linux, for Windows, for anything, it's a high availability solution. When you think about a high availability solution, it means you have two or more servers working together in order to provide high availability for the workload. So think about that for a second. For ages, ever since we've heard the word clustering in the tech world, we think about, other than the fact that we have clustering for uh, uh, data analysis and machine learning and all that kind of stuff. But high availability is always associated with clustering. And so when you start thinking about availability groups running on top of available clustering, you're thinking availability. You're thinking, oh, we need to provide higher availability to our workloads. And now you're telling me I can run availability groups, SQL Server 2017, that is, onwards, without a cluster? Which is kind of ironic because you're telling me I'm running availability groups that won't be highly available. That's one of the reasons I'm not a big fan of it. Okay, it is one of those things where, and again, that's Microsoft marketing right there. It is one of those things where it is very difficult to detach or to change a way of thinking that's been embedded in someone else's mindset for years. I remember working on my very first availability group project back in 2013. The client went ahead and purchased very expensive hardware. They had this massive, like a large storage area network. And I told them, you don't really need a storage area network for your availability group. Like, why not? It requires a cluster, because for years they needed a storage area network to build a cluster. And so when they decided to deploy availability groups, they thought they needed it, right? Because it's how they've done it before. And so they are bringing with them everything that they know about failover clustering with availability groups. With availability groups, you don't need storage area network. Hence why I'm really not a big fan of this when it comes to deploying availability groups on a clusterless. Gilda, how are you? Happy New Year. A little bit sidetracked there. Deploying availability groups on quote unquote clusterless, because we're simply not talking about technology here. We're talking about the way of thinking that people have. And of course, Microsoft did specify in the documentation that this is not a high availability solution. It is a disaster recovery solution, or in fact, the way they marketed the technology is really about scaling out, right? Scaling out your readable secondaries. I just wish they don't call it availability groups when it's not running on a cluster, right? Because there is no availability, right? And so, like I said, that's one of the reasons why I'm not really a big fan of deploying availability groups without a cluster. Because for one, you're already spending on very expensive SQL Server licenses and you don't have high availability. I would rather focus on high availability first for availability groups and use something else for disaster recovery. Backup copy restore is still a thing. Log shipping is still a thing. They're still supported, so might as well use them. Okay. And I know I spent too much time on that because it's one of those things where when a client would ask me about it, I would first start asking the question, what do you need it for? In the same way, I forgot who asked this question. What do you need it for? Why do you want to run SQL Server on non-clusters? Why do you want to run SQL Server on, or rather availability groups, because I'm referring to this. Why would you want to run availability groups on a platform that is not highly available? Just some food for thought there. Okay. This is another one of those questions that came in, and I wanted to share a slide as well. Can you please list all of the SQL Server HADR solutions and what are their uses differences? Interesting. I wanted to share my screen real quick to kind of point out some things. There. I don't know if you can see my screen. I don't know if you know what this is. I do a little bit because I used one of these, like those bronze things, when I was in university. Yes, machine shop, part of our quote unquote lab. Our definition of lab is totally different from our tech people's definition of lab nowadays. What do you use this for? If you don't know what they're for, then it probably means you don't need them, or maybe you need to start learning about them before you even hurt yourself. I remember using one of those and cut myself back then. The reason I'm mentioning this is because when people ask about, hey, can you please list all of the SQL Server HIDR solutions and what are their uses differences? Uh, my first response and my first instinct is that if you're asking all of these features, technologies, which it only means one thing, and you're not quite sure yet. And I'm saying yet because you haven't done your research yet. You haven't had the experience yet, or maybe you just hadn't had the opportunity yet to use them, right? The first thing that you have to think about, and I'm guessing this was a question from a SQL Server DBA, is first go back to your job description. List all of the things that you're responsible for. One of them is high availability and disaster recovery. Okay, um, and you have to look at the items on your job description to see um, what are you responsible for as far as high availability and disaster recovery? Is this just about backups? Is it about providing high availability? Is it about extending your database infrastructure to a disaster recovery site? What are your main responsibilities? And then after knowing what your responsibilities are, ask better questions. And I don't mean this isn't a good question. What I mean by better questions is that stop looking at features like, yeah, I'm going to use transactional replication, I'm going to use availability groups. Stop thinking of features and start thinking of problems that you need to solve. Okay, because I can tell you all about how you can leverage read scale availability groups. I can tell you how to do it, but if you don't know why you need to do it, then it's useless. Okay, just like the tool bit, the tool set that I showed you. I can tell you every single thing about those, and interestingly, I kind of know what they are, having worked in a machine shop back then. Um, but if you don't know what you're going to use it for, then it's useless. Okay, start with knowing what problems you need to solve before you look at your solutions, because the solutions don't matter. In this case, features. The solutions don't matter if you don't know what problem you need to solve. Okay. Jan Martins was saying, but it allows us to have readable replicas on different data. Oh, I'm guessing this was about the SQL Server always on availability groups without any clusters. And yes, it does allow you to have readable replicas on different data centers, but keep in mind, and I'm going back to this question over here, clustering of SQL Server without Windows clusters. It may allow you to do that, but you're not highly available. You don't have a high availability. And like I said, I did emphasize on the word practical here. If your goal is to have readable secondaries, you will be paying for license for both your primary and your secondary. You might as well have high availability with that. Okay, because you're already paying for very expensive SQL Server Enterprise Edition licenses when you implement read scale availability groups. So think about that for a second to make sure that you're not just doing something and not getting a return. I'm going to put on the hat of a CFO or a CIO here. I'm not going to invest on something and pay for something if I'm not going to get a return on it. Okay, that's how the big bosses are thinking. I'm not going to be spending on something if I'm not going to be getting any return on it. And so think about that for a second before you even start to think about read scale availability groups without failover clusters. What is your goal? Is it just to allow readable replicas? Because you can do that with transactional replication and standard edition license, by the way. Yep, standard edition, transactional replication. If all you need is to have readable secondary. I don't even want to call them readable secondaries. I want to provide the opportunity to run reporting workloads on my secondary or tertiary data center. Okay. So that's the second question. Yep, about the different SQL Server HA. I know that's not exactly what you're thinking about when you ask that question, but again, I discourage people from just looking at the features, the technology, because that's easy. But if you don't know how to use it, no, not how. If you don't know what to use it for, then it's useless. Now, it's the conversation around, do I use availability groups? Do I use backups? And some people would jump at the opportunity to implement an availability group solution because it's, number one, it's good on the resume. When you tell people I built a failover cluster, I have built an availability groups by myself, it's good on the resume. But the thing is, if the problem can easily be solved by implementing a backup copy restore process where you have a disaster recovery strategy, then why use something that's complex? Okay. Third question in the queue. Oh, by the way, I did shorten the question sometimes just to make sure that I can fit it in the banner. I think a maximum of 200 characters can fit in the banner, I think. Question about listener configuration in always on. I'm not quite sure if this is always on failover cluster. No, I'm kidding. It's a marketing term and people get confused. I'm guessing this is availability groups. Question about listener configuration in always on. Availability groups. Like what port we should be using. Can we use 1433 or shouldn't be? Why it is important to have a listener and what happens when we don't have one. Okay. And I also wanted to share another picture here to kind of illustrate what a listener is. I kind of look at a listener as your smartphone. You carry your phone everywhere you go, even when you go to bed or you go to the toilet. Weird. Yeah. And so anybody can call you regardless of where you are, even when you're on the car. Hopefully you're not picking up the phone while you're driving. Please don't do that. You can accept calls, receive calls everywhere you are, whether you're in your home, whether you're in your mother-in-law's home, whether you're in the toilet, anywhere. That is what a listener does. The people calling you don't really care where you are. They just know when they call you, they're going to get to you because you always have your phone with you. That's just it. Okay. You could be on the road and people can still call you. That's what an availability group listener is all about. And again, I'm trying to simplify this as much as I can because it is more than that. When you think about it, we barely pay attention to how this thing actually works. There's a lot of networking happening underneath in order to make that smartphone accessible anytime, anywhere. And that's exactly what is happening on the available group listener part. The listener is simply a network thing. And I say network thing because it is a combination of an IP address and a network name. Your network name is resolvable through DNS. And if your client application wants to connect to the database, if it contacts or if it connects to the instance name and puts that in the connection string, your availability groups might be there at some point, but you'll never know. Something might happen in the process, a failover might happen, and then your applications can no longer insert records on your databases. Why? Because the failover happened and it's no longer the primary. Okay. When you have a listener, you are guaranteed to be redirected to whichever replica is working as the primary replica. And I say this is simply a network thing. In the same way that your contacts can call you through your phone, think of your listener name as your phone number, or I don't know, on FaceTime, whatever that ID is. It guarantees the client application to contact you wherever you are. Client applications are guaranteed to be redirected to the primary replica regardless, because the primary replica could be running on server A today, maybe server B tomorrow because of a failover. And that is the reason why you want to use a listener. You don't need to use a listener. Mind you, database mirroring worked without something like that. Yes, you just have to make modifications to the client application every time a failover happens. Or you, in database mirroring, you're adding a connection string parameter, the failover partner connection string parameter. But what about applications that don't support those connection string parameters, right? A lot of legacy applications do not support something like that. And that is where the listener name comes in, okay? It's a floating name with a floating IP address. People call it floating IP address, but they don't call their phone numbers as a floating number, right? It's a floating name and a floating IP that moves around wherever it is. Now, a follow-up question to that is, what port number should we be using? What port number should we be using? One of the reasons I like using port 1433 is because I want to make my network administrators happy, or the clients' network administrators happy. Why is that? Because for one, you already asked for exemptions to port 1433 for your instance names. So if you're running on default instances, your client applications are connecting to your SQL Server instances and your databases using the instance name, which happens to be a network thing, right? The instance name is a network thing because the only way for your client application to connect to the SQL Server instance is if they can find that thing on the network. Okay, and so your network administrators already know, hey, we're going to give access to client applications, or I'll use a network administrative terminologies here. We are going to create firewall rules to allow inbound and outbound traffic for port 1433 on this number, or IP address, phone number. And I'm using network administrative terms here because this is kind of like the conversation that you're going to have with your network guys. What IP address, what port number? They really don't care about the network name thing, right? For network administrators, it's the IP addresses, the MAC addresses, the numbers, port numbers, and so on and so forth. The reason I'm simply using the port 1433 is because they already know. I don't need to argue with them about, hey, why port 1479? They already know that 1433 is for SQL Server, and all they're doing is adding another IP address in the firewall rule to allow 1433. Because mind you, if you've already asked for exemptions for port 1433 for the SQL Server instance, a listener name is a totally different IP address from that of the machine. It's a virtual IP address. So you may have asked, because I've heard some people say, we've already asked for exemptions for the instance name. Why do I still need to ask for a firewall rule exemption for the listener name? Because your listener name is a totally different IP address from that of the machine. Okay, so that is why you would need, if you decide to implement a listener name, I would suggest that you do, because you don't really need it. Availability groups don't really need listener names, unless, of course, you're using readable secondaries and you're doing read-only routing of readable secondaries. Then you would need a listener name. But if you need to implement a listener name, if you want to, 1433 is the easiest because your client applications don't really need to change anything other than the connection string parameter, right? Because the default, they would connect to 1433, okay? Yes, I just want to make my network administrators happy. Why is it important to have a listener name? And what happens when we don't have one? Well, if you don't have a listener name, you're going to be working harder. Yes, if a failover happens, your client applications won't be able to write transactions into the database, and so you have to change the connection string, you change the pointer to the new primary replica, which means you have to implement monitoring so that you know exactly what the primary replica is. And there are workarounds there, but again, the idea behind that is just to make life easy for you. I did say practical SQL Server high availability and disaster recovery. I'm just being practical. You have it, you can use it. When a failover happens, you don't need to worry. Because when you think about that, if you have like 1,500 client applications, and I'm talking about point of sale systems where you have like dumb terminals connecting to the database. If you have 1,500 client applications connecting to your database, I wouldn't want to go and modify all 1,500 client applications just so I can redirect them to the new primary replica. Okay, that is what it is for. Third question. I can't believe this is just a third question. Why do you need to take a log backup of a corrupt database before restoring? I'm assuming that the question was based off of a database in full recovery model. And I am going to show you another picture that explains why you may want to do that. Why would you want to take a log backup when a database is corrupt? Yes, it took me a while to find a picture like this. A database that is corrupt is like a pail, a bucket filled with water, but with a lot of holes. Up to a point where you have the holes, up to that point where you have the holes, anything above that the level where you have holes is useless because that water is going to go out the pail, the bucket anyway. Okay. Now imagine if your hole is just right in the middle. Are you going to throw all of the water below the hole and replace the pail? Of course not. Because what if that's gasoline and you need that for your car? You're stuck in the middle of nowhere in the winter and your gas tank is empty. You are so not going to throw away the gas, the petrol for our friends from across the pond, from down under. You're not going to throw away everything in the bucket and then replace the pail or the bucket, right? What you would do is you would salvage as much as you can from that bucket before you go ahead and replace it. I hope that is making sense. That is the reason why you need to take a log backup of a corrupt database before restoring. You want to salvage as much data as you possibly can. Because for one, you don't know exactly which part of the database is corrupted. Sure, I don't want to get into the details of diving into the data page and the corrupted page, but your CheckDB would tell you which file ID and page ID and all of these things. It will tell you. But where is that file inside a database and how far away is that? Are you sure that even if that data page is in the middle of the data file, it's not going to affect everything else? And how much data is in the transaction log that you are okay with losing should you decide to just restore a corrupted database from backup? Of course, we're also assuming that your backups are okay. One of the reasons I tell my customers, I don't really believe in backups. I don't, because I've seen a ton of backups that don't work. Yes, I've seen a ton of backups that don't work. I would rather test whether or not my backups actually work. That's one of the reasons why you need to test your backups regularly. And part of that is, of course, when you're in a live situation where you have corrupted databases, is to take tail of the log backup, right? It's called the tail of the log backup before you restore from backups. Okay? I like the bucket analogy there because you're not going to throw away everything in a bucket just to replace it. Okay? You would salvage as much as you can from the bucket. This is an interesting question, and I hope, I don't know who's on this session right at this point. How does parallel redo threads teacher and secondary database actually work? I'm assuming that this has something to do with availability groups running secondary replicas. And prior to SQL Server 2016, and I really want to understand the context behind the question. These are the questions where I ask more questions to really understand the context behind it. Starting with SQL Server 2016, Microsoft introduced a parallel redo for your secondary replicas. Okay, prior to SQL Server 2016, the redo thread is a single-threaded operation, or a single redo thread is the one responsible for the redo process on the secondary replica. They introduced a parallel redo. Excuse me. They introduced a parallel redo in SQL Server 2016. Now, I wanted to show you another picture. If I have that here, the parallel redo. Think of the parallel redo on your secondary replica as a bus depot. If people are taking buses in lockdowns, because we're in a state of lockdown, the entire province at the moment. Think of it as a bus depot where you have a bus dispatcher. Okay, there is a redo thread responsible for dispatching redo threads across the secondary replica. Think of this guy, the bus dispatcher, as that. Okay, and imagine in a bus depot you got like multiple buses. One bus going to the city, one bus going to a different state or different province, one bus is just local. And the bus dispatcher's job is to guide passengers to take which bus they need to take. Think of the dispatcher again as the redo thread responsible for sending redo workloads on every single database. Think of the buses as a database. Okay, there could be times when a backlog could happen. One of this example is when you are doing a schema modification on the primary replica and you have a readable workload on your secondary. Okay, I'm going to stop sharing here so that I can see some of the comments. An example of that is when you would have a schema modification on the primary and you have a readable workload on your secondary. In fact, when you start to think about this, because I was reading the follow-up to this, is that when there is a DDL statement happening on the primary replica, the secondary's redo thread is blocked. Okay, this is not even a redo question. This is not even an availability group question. This is a lock compatibility question. Keep in mind that a DDL statement, or rather a redo, needs to acquire a schema modification lock, especially if you're doing something on the primary replica, like for instance, you are changing a column type or data type. That is being redone on the secondary, and the redo thread needs to acquire a schema modification lock. Your secondary or readable secondary workloads need to acquire a schema shared lock. Okay, and this is an incompatible lock. Do a quick search on lock compatibility, and this there's this table from one of the Microsoft documentation that says these two locks are incompatible. They are. In fact, like I said, this is not even an availability group question. This is more of a lock compatibility question. So when you're doing something on the primary replica that would require a schema modification lock, then your readable workloads would be blocked. And sometimes it depends on which one comes first. Now, here's the thing. Does the redo thread really block everything? I'll go back to that analogy of the bus depot where you have the bus dispatcher. If somebody's coming up the bus that goes to the city and he's on wheelchair and it's taking forever for him to come up the bus, does that mean everything else is blocked? No, there are other buses in the bus depot, and the other passengers might not be going on the same bus as this guy is. Okay, there are other buses, so the bus dispatcher could redirect the other passengers to the buses that they want to come on. And I hope that makes sense. The only one that's blocked is the bus where the guy in a wheelchair is getting on the bus, because it will take a while before that guy gets on his bus, right? It may appear that everything else is blocked if all of the passengers in the bus depot is actually getting on that bus where this guy is getting onto, right? And so it may appear that everything is blocked, but in reality it isn't. Plus, with parallel redo, and I'm tying everything back together with a log compatibility with readable secondaries parallel redo, a maximum of 16 threads per database is allowed. I don't want to say allowed, but a maximum, that's the limit. Maximum of 16 threads per database. So per secondary replica. So if you imagine if you have like a 32 core CPU, and how many threads, you could do the math, and you got like 25 databases in your AG. So there will be cases where some databases would definitely have 16 threads, while the others will be in single redo thread mode. So when that happens, well, it may appear that some of the things are being blocked, because you know how it is. I'm going to tap into the thread model, worker thread model in SQL Server. You got one database having all of the worker threads, and one database that only has one thread. So you may think, oh, this guy's taking much longer, and you think it's taking much longer. You start to think things are getting blocked, but it's not. So really dig into what is happening on the secondary replica or rather the primary replica while this is happening, and what else is going on. Like I said, this is more than just, this is not really an availability question. It just so happens that the log compatibility is now affecting your secondary replica as a side effect of this. Okay. Another question in here is, and this has something to do with deploying, I believe, availability groups or failover clustered instance, or depending, across multiple data centers. Is it imperative to have a domain controller, AD/DNS, in every subnet of a multi-subnet cluster? I don't want to say it's imperative, because it really depends on how you design your multi-subnet cluster. Okay. First thing that come to mind when DBAs and sysadmins hear the word multi-subnet, they immediately think multi-data center, right? In reality, though, you may have a cluster sitting in the same data center. They're probably on two separate server racks, but your network administrator made a decision to segment the network in a way where one node could be on a totally different subnet than the other. Okay. I don't know why they would do that, but from my experience working with network administrators, sometimes it's more for filtering and quality of service. They want to make sure that they're segmenting traffic in order to achieve quality of service for certain workloads. Like, for instance, backups. If you're taking enterprise level backups, you're taking the entire, depends on what backup tool you use. You're taking up the entire bandwidth. And so what network administrators would do is they would segment the network, have the backup workload go through a dedicated network. I remember when I was working as a data center engineer, we standardized on 4 network adapters, at least. And I'm not even talking about clusters here. I'm talking about standalone machines. One for production network. This is the network that everybody uses to contact the service. So if it's a SQL Server machine, this is where the client applications would connect to. It's the same network that the machine uses to authenticate with Active Directory and resolve IP addresses with DNS. We have a management and a monitoring network. This is the network that we administrators use. We use this to connect to the machine using remote desktop. We use this to connect to the machine and implement monitoring. We use this to connect to the machine with SQL Server Management Studio. Third is the backup network. We have enterprise backups, and we stream the backup through this network, not the production network, because you know how large these backup streams are. So we have a dedicated network for that. And the fourth network is the DR network. We also stream our backups in our DR strategy. If, let's say, we're using for SQL Server log shipping, database mirroring, we're using that network for it. And we standardize on for networks. And so going back to the question, what is your definition of a multi-subnet cluster? Is that a cluster that spans across data center? Is that a cluster that just spans multiple network subnet, but they're really sitting right next to each other, right? Because if they're just sitting right next to each other in a data center on different server racks, but they just happen to have different network subnets, then you don't need a domain controller slash DNS server per subnet. Why? Because it's just like driving on the freeway for our American friends, or the highway. If you're going through the highway and you want to get to your destination, it's a lot faster, right, to use that lane that barely has, well, of course, you have to follow speed limits. It's a lot faster for you to use that lane where you have less cars, right? But if it's the same lane that everybody uses, if it's the same, if you only have one lane, so what's the point? In this case, the reason why people recommend that you have your domain controller and your DNS server on a secondary subnet is because you don't want the servers in that second subnet to cross the wire just to authenticate. Okay, and I'm talking about multi-subnet clusters that span data centers, not server racks, but data centers. Because think of it this way: the failover clusters need to authenticate to Active Directory. If you're leveraging Active Directory, that is, they need to resolve the name, and so they need to be able to contact your DNS server. So imagine you have a data center in, I'm going to use North America and Europe here. If you have data centers in New York, and then you have a data center in the UK, you have a stretched cluster. If you don't have a domain controller and a DNS server in your UK data center, the nodes in your UK data center would have to cross the Atlantic just to authenticate. What happens if you cannot authenticate because there's some network maintenance going on? Well, the cluster node won't be able to do what it needs to do. Okay. In addition to that, crossing the Atlantic is longer than it is to authenticate on a domain controller that is in the same data center as your UK cluster node. Okay, so it is not imperative unless the network latency demands it. I've seen cases where a client would implement a multi-data center setup, but their data center is less than 50 miles or 200 miles, but then they have very expensive network connectivity, like really fast network connectivity between those two data centers, which does not warrant an extra domain controller slash DNS server. But again, it all depends on how you classify multi-subnet cluster. Is it across data center? Is it simply just multi-subnet, but they're still in the same data center, just on different server rack? Okay. Oh, I got one more question here. Okay. I didn't realize they got like a variety of questions ranging failover clustering, availability groups, and database and data corruption. In case if there is something which stuck on translation log, I'm guessing this is transaction log. I didn't change the wordings in here. I just copied and pasted. In case there's something, you know what? It is annoying. Why don't I just change this into transaction log? Transaction log file. Yes, and show. There we are. In case there is something which is stuck on transaction log file on all VLF and it did not truncate under that case, what should we need to do? And system keep on saying that transaction log is full. I'm guessing this has something to do with you trying to run transaction log backup, and then you can't because the transaction log is full, and you're trying to figure out what is causing your transaction log to not truncate. And of course, I'm also assuming that your database is in full recovery model. Okay. The one misconception that a lot of people think is that a log backup will truncate the log. It won't always. Okay. A log backup will not truncate the log all the time. Okay. You have to understand what's going on under the covers. When you run a transaction log backup, it will store all of the committed transactions that are freed up for log truncation. Okay, and it doesn't really matter if you have an availability group, if you have database mirroring, if you have transactional replication. It doesn't really matter. Okay, the idea here is that something is preventing the log file from marking the VLFs for truncation, meaning the VLFs are still active. Okay, if there is something that is stuck in a transaction log, then you would have to find what transaction that is. Okay, the biggest challenge here is when you're dealing with a high availability solution like availability groups, or I've seen this in the past with database mirroring. Big internet company I worked with a couple of years ago, where they had a database mirroring setup. Their secondary replicas on another data center, and out of nowhere, they could no longer insert records into their primary database or principal, because database mirroring. And then I found out that they powered down the machine on the secondary data center, and the virtual log files on the primary database could not get truncated. And at that point, you cannot even do a log backup, because a log backup is a system transaction, and so you cannot even write a transaction to the database because the database log file is full and it took up the entire hard disk space. And it is challenging because you need to do two things. One, stop that thing from happening, and two, make sure that your system is still highly available. Every minute or every second counts when you're in that situation. Okay, so the first thing that you need to do is find out what is causing that VLF to be stuck. Query the DMVs and check what is causing that VLF or that database to have virtual log files to be marked as active. Could be a long-running transaction, right? It is also important for you to understand how the transaction log works. I can't remember if I have a YouTube video on explaining how the transaction log works, but a long-running transaction, even if it's just a database in simple recovery model, okay, even if it's a database in simple recovery model, a long-running transaction is going to prevent VLFs from getting truncated, because with a simple recovery model, a checkpoint would truncate the log. But if there is a long-running transaction, any VLFs starting from that long-running transaction will not get truncated. So you really need to figure out what is causing that. Okay, what should we need to do? Well, you just have to figure out what is causing that. If it's a long-running transaction, you really have to decide, can I kill this transaction? Because, and I've seen cases where, again, it is a matter of deciding, I have a high availability system and the database can no longer be functional. Why? Because when the log file is full and it can no longer auto grow, your database suddenly becomes read-only, meaning you can't insert records into it. And so you have to now decide, do I kill the long running transaction? Do I keep the database up by adding another log file. I don't recommend it lightly that you add another log file, but that's exactly what I did for this client. I can't even remove the database from the mirroring session back then, and so I had to create a secondary log file. Again, not something that I would recommend under any circumstances unless it's really emergency, and that's the only option you have. And at that point, you really have to make a decision. Do I kill the long run transaction so that I can free up the virtual log file so that I can truncate the log, or do I do something else? That's why it's a judgment call at this. And that's why you also need to keep in mind your recovery point and your recovery time objectives when you have high availability in place, or high availability solutions in place, like availability groups or even failover clustered instances. Okay. Saying the transaction log is full. Again, when your transaction log is full, there is no way that you can do anything else. Even take a log backup at some point would cause your transaction log backup to fail. Okay, and that's why one of the things that I would highly recommend, and something that you should have as a DBA, is proactive monitoring. You need to keep your eyes, or your monitoring's eyes, on what is going on. Even stuff like, oh, your transaction log file is growing at a a fast rate and it's starting to fill up your drive. You need to take proactive actions before something like this happens. Okay. But of course, the only time that you figure this out is when it happens, because you didn't have monitoring in place. Big fan of monitoring. You wouldn't drive a car without a dashboard, or you wouldn't drive a car with a dashboard that isn't working. Because when you run out of gas, you probably, if you're stuck in the middle of nowhere, you're probably not going to be looking at your dashboard and say, oh, my gas is still full. Okay. Proactive monitoring is key. So make sure that you do have monitoring in place for stuff like this. And I did say practical high availability and disaster recovery in the title of the session. And so it is imperative that you do have monitoring. Even if it's a simple thing, because some people would say, oh, monitoring tools are expensive. Well, is a monitoring tool really expensive? It's just like saying the dashboard is expensive on your car. Might as well take it out. Okay. Focus on what is really important. Is high availability important? If it is, put in monitoring. Okay. Implement the right processes in place. Implement the right strategies in place. And I say process, and I focus on a process because the process could be automated. You could use other tools for that, so long as you have the process locked down and tested. By the way, I emphasize on testing, not just your backups, but your processes in general. Because remember, in a complex high availability and disaster recovery solution, it's not just you on the team. Somebody asked the question about restoring a database from restoring a corrupt database. If you have enterprise backups where your database backups are first stored locally and then stored on tape, and then the tape is stored off-site, I can't just wait until whoever's taking those tapes off-site to call me back. I need to have a process in place where I can call them anytime. It's part of the service level agreement. I can pick up the phone, call them so that they can deliver the tape to me. Because if I don't have that, then right, so that it is important for you to have a simple, and I'm emphasizing on simple because being able to provide practical high availability and disaster recovery solutions, simplicity is king. King, whatever. It really depends on not just your skill set, but how simple it is. Okay, you cannot rely on you being there 24/7. You need to be able to have a process where I can hand it off to the most junior guy on the team, so that when I'm on vacation, maybe you're away on a holiday and something goes wrong, you need to be able to give the document to them or the process to them, and they can run with it. Okay, because you're not the only person on the team. Now, if you're the only person on the team, even more so that you need somebody to back you up. I always tell my customers I may be a high availability guy, but I'm not always highly available, because that's reality, right? I take vacations, I sleep. Yes, I do like my sleep. And in the same way for you, your health is more important than your disaster recovery or your high availability solution. Your sanity is more important than your high availability and disaster recovery solution. Make sure that you prioritize that. And I'll end with this because we're almost out of time here. I remember the first time that we were running the SQL Server Always On Availability Group training class back in 2017. We were on this training class and one of the attendees bailed out, literally bailed out. The next day, she was, she sent an email before the start of the class. She was apologizing. And the explanation was there was a hurricane ravaging the state of Florida and they had to evacuate. In a real situation, in a real disaster situation like that, your first instinct is not to fail over all of your failover clusters or your AG, or that's not your first instinct. Your first instinct is your safety. And this is exactly what she did. They were forced to evacuate, left everything behind. She just grabbed her laptop and a few clothes and then left. 5 minutes in, they were on the road heading north of Florida. And the thing about high availability and disaster recovery is this: your health, your safety is more important than any of the high availability solution. So you want to make sure that you're designing your solutions to be practical, and not just from a financial and economic point of view, but also from an execution point of view. I've seen disaster recovery solutions where just reading the document would make you vomit because there's so many things going on, right? And when there is so many things going on and it's very complex, I doubt that one person will be able to execute all of them. Okay, and this is not a one-man show. This is a team effort. So you need to bring everyone on board whenever you are invoking a DR strategy or even restoring from backups. This is what Practical SQL Server HADR is all about. It's something that you and your team can do that accomplishes the business goals and solves a business problem. Anything else is just intellectual conversation. All right. And that is about it for this week's. And I say this week because I'm thinking of doing this every week. So next Friday, I will post a link to the Google Forms where you can submit your questions ahead of time. And I like collecting those questions because I can use pictures like what I did today to illustrate and explain some concepts and make it as simple as I possibly can for people to understand. Tune in again next week where I answer the most common questions that people ask, not just on forums and news groups, but people that would reach out to me and ask questions for. Of course, I would give some context around it, because if you're going to ask me, hey, can you troubleshoot this? I'm not Microsoft support. Or do you mind doing this? No, that is more of a consulting kind of work. These are questions that need immediate answers, and the answers you need. The answers that you need, not the one that you want to hear. Okay, and the answers that you need might not be the one that you want to hear. Like I had a client back then where they're moving to the cloud, and when they did the math, it was very expensive. And I said, then don't do a lift and shift. They were surprised when I said that. Yeah, don't do a lift and shift. Move to the cloud, and we re-architected everything and made life easy for them. That was not what they were wanting to hear back then, but that's exactly what they need. So tune in again next week for another AMA session where you will get the answers that you need that are practical and actionable. Because what good is information if it's not practical and it's not actionable? All right. Enjoy the rest of your weekend. I'll see you again next week. Goodbye.